Graph on the left, the graph that is going through 1 on the y-axis has a y-intercept of 1. Well, that would be your exponential function. And in this case, it's the exponential function y equals 2 to the x. So you saw him draw that a few minutes ago. So there are certain points on here that make sense. The point 1, 2. So if you raise 2 to the power of 1, you get 2. 2 to the power of 2 gives you 4. 2 to the power of 3 gives you 8, and so on. So these are the points that you would get on a 2 to the power of x graph. But he also pointed out that if you were to reflect that graph across the y equals x line, so this dotted line here is the y equals x line, that you get the inverse function. And that inverse function basically flips the x with the y. So instead of the 1, 2 point, it becomes a 0.21. The 2, 4 point becomes a 0.42, and so on and so forth. Both functions are increasing. I'm just going over some of the stuff that he just talked about. But this function down here is equivalent of x equals 2 to the power of y. But what if you wanted to make this a function that was y equals something? Well, that's where we're going to go with this. We're going to go with what the nature of this line, which is the inverse of the exponential function, really is. What do we call the function that generates this blue line, which is the inverse of the exponential function? Well, that's what this is. It's a log function. So you may have heard of logs before because maybe other teachers in grade 11 introduced you to the concept of logs. But let us formalize that now, right? I'm assuming that you have heard of logs. You've certainly seen the key on your calculator. And some of you have used that key before. But we're going to get into, like I said, the intricacies of what logs are and what they do. So if A is equal to b to the power of c, so for instance, he was talking about y is equal to 2 to the power of x, then if you want to look at this in logarithmic terms, then you would say that the log base b, every log has a base, and that base corresponds to whatever this base is in the original function. This function has a base, or this equation, a equals b to the c, has a base of b. Well, in the log world, that becomes the base of the log that you're dealing with. You can have different bases for different logs. So if you're going to be talking about converting from an exponential function, and whatever was the base in the exponential function becomes the base of your log. So the log base b of a, of this number on this side, is equal to c. Why is equal to c? Because here is a statement I'm going to repeat more than once today. Think of a log as an exponent. The exponent over here in this expression, a equals b to the c, was c. When you take the log of anything, what you're ending up with is an exponent. So in this case, you're ending up with c because c was the exponent over here. So it makes sense for you to say that the log base b of a is equal to c. Okay? So in this case, if 4 squared is equal to 16, again, 4 is the base, so we're going to take a base 4 log. The base 4 log of 16 is equal to 2. Why 2? Because 2 is the exponent over here. And 4 was the base, that's why it's the base 4 log we're talking about. Same thing here. If 3 to the minus 3 is 1 over 27, and he talked about that, I want to remind you that 3 to the minus 3 means the same thing as 1 over 3 to the power of positive 3. Right? That's something you need to remember. He talked about that a few minutes ago. If the exponent is negative, another way to make the exponent positive is to flip it over and turn it from a numerator into a denominator. So instead of saying 3 to the minus 3, I'm just going to say 1 over 3 to the 3, which is the same thing as 1 over 27. And that's why the base 3 log, again, here's my base of 3. The base 3 log of 1 over 27 is the exponent minus 3 is equal to minus 3. Down here, 10 to the power of 2 is 100. I'm just making statements on the left. This column on the left is just statements that are true. 4 squared is 16. 3 to the minus 3 is 1 over 27. And this one here is also true, that 10 squared is 100. So if 10 squared is 100, then the log, oh, I didn't put a base here. Why is that? That's because when you don't see a base, the base is assumed to be 10. So let me write that on the side. No base stated means base 10. So whenever no base is stated, just assume it's a base 10. If you look at your calculator keypad, you see a log key on there. That log key has no base. Well, some calculators have ones where you can, in fact, find the log in any base. But if your calculator doesn't have a log in any base on it, just has a log key, then that's going to be a base 10 key. Okay? So that means the base 10 log of 100 is 2. Okay? All right, so let's see if this makes sense. What would the log of 10,000 be? Now remember that I said that if no base is stated, it means that the base is 10. So who can tell me what the log of 10, without going to your calculator, what's the log of 10,000? In other words, and I see some answers perfect. Jeremy, Emily, and Isaac have come in with the correct answer, and that's equal to 4. Now, there is a very special base, which you also have on your calculator, and it is the base E. Now, what is E? E is not a number like 4 or 6 or any of these numbers up here that we've been looking at for bases that we looked at before, 4 or 3 or 10. The base of E is this funny looking number here. It's 2.71828, and it doesn't stop there. This is approximately equal to 2.71828 because this is what we call an irrational number, just like pi. You've been told that pi is irrational, and all irrational means is that you cannot represent it as a fraction, right? This number actually is non-repetitive. So in other words, it doesn't have a pattern to it, and it goes on forever. So it's non-terminating, right? And it's also, there is no pattern to it. You might say, oh, that's like 1/3 then, because 1/3 goes on forever. Well, 1/3 is, in fact, repetitive because it goes 3, 3, 3, 3, 3, 3, 3. So there's a very predictable pattern to it. What is the significance of E? Oh, Jeremy, when you get into calculus, which I assume you will at some point, you'll have a lot of fun with E. There is a function that I got fascinated with when I was learning calculus, and I couldn't figure out why it had its maximum point, like a vertex, at this particular value here. It's a very special number which was devised by a mathematician called Euler, and we'll sort of get more into it. I think you want to hold off on getting more into it when you get into calculus, because it's a very, very special number in math, which, like I said, is like pi, which is also a very special number in math. But it's a constant. It's just a number. It's not like it has any, it's not a variable, right? You might think of pi because you see it there with a symbol that is, it's not a variable. E is an actual constant. It has this particular value, 2.71828, and goes on forever and ever, non-terminating, non-recurring. So if you see, there's another key on your calculator that's called the ln key or the natural log key. It's usually right beside the log key. So the log key will say log, and I'd say in 99% of the calculators that I've seen, the next key either to the right or to the left of it is the ln key. And the ln key is assuming a base of E, 2.71828. So the ln of A means the base E log of A, where E is this particular constant. So what do you think the ln of E itself is then? Can anybody tell me what that is? If I took the ln, which is the base E log of E, what would you think would be the response to that? Right? What's the ln of E? Can anybody come up with an answer for that? No? Nobody has an answer? Jeremy thinks it's 1. What do other people think? The base E log of E, the ln of E. Well, let me ask you this. What is the log base 5 of 5? What do you think the base 5 log of 5 is? Right? What do you think that is? That is 1. Right? What do you think the log base 10 of 10 is? What do you say that is? Remember, I didn't put any base there because if there is no base, it's assumed to be 10. So that's also equal to 1. So since we're saying that the ln is a base E, the base E log of E is in fact equal to 1. So you're right about that. And Joel is right about that, and Jeremy is right about that. So if this base matches the thing that you're trying to find the log of, the answer is always going to be 1. The answer is always going to be 1. All right. So let's see if we can extend our understanding of this thing called logs. Oh, I have one more for you. What do you think the log in base 5 of 1 is? Can anybody give me that answer? The log base 5 of 1, based on what we've been saying all along. Okay, Jeremy thinks it's 0. What do other people think? I'm not going to confirm or refute that. I'm just asking what other people think. He thinks it's 0. Anybody else have either agree with Jeremy or have a different answer? I'm open to other answers. And Joel is agreeing with Jeremy. Really? Anybody else want to either agree? Agree. Okay, good. So log base 5 of 1 is 0. How about the log base 10 of 1? What do you think that is? I agree with this one, by the way. This is equal to 0. How about the log base 10 of 1? What do you think that is? The log base 10 of 1. It is also 0. You're quite right about that. So in other words, in any base, apart from base 1, which we never use, there's no point in using base 1, but in any base, when you take and including the ln, if you try to find the log in any base of 1, the answer is always 0 because 10 to the power of 0 gives you 1. 10 raised to any number raised to the power of 0 does give you 1, something that was mentioned in the video that you just saw by Mr. Richards. Okay, so let's do this. Let's rewrite some of these things in log form. I'll do the first one for you. Here's a statement of fact. 2 to the power of 4 is 16, or 16 is equal to 2 to the power of 4. This is a statement of fact. So here's what this means in logarithmic terms. It means that the log, oh, I meant to say log, let me fix that, that the log base 2 of 16 is equal to 4. That is the log form, right? Again, I'm using the base, which is 2, as the base of the log. The exponent is what I'm going to make it equal to, because any log I'm taking is basically going to give me an exponent. So log base 2 of 16 is equal to 4. I'm going to do the same thing here. If m is equal to n to the 3, then the log base n, right, of m is equal to 3, right? So again, I'm using the base as being the base of the exponential form. There's my base right there. And then I'm making the exponent what the log is equal to. In this case, it's 3. How do we write the superscript? The superscript. Well, I'm actually writing a subscript right now, Jeremy. Right? That's what I'm writing now. This is, and here is a subscript. Superscript would be like when you're writing something to the power of, but this is a subscript. Yeah. Like in a chat. Oh, that is a good question. That is a good question. When we get to use, of course, if you're using the whiteboard, that's not too hard because I can show you how you can do it in the whiteboard. And if you're using D2L, I can show you the math editor there for you to be able to do that. All right. But in terms of the chat, I don't have a good way to show you how to do it in the chat. I have, if I think of one, I will let you know. Okay, let's move along. 3 to the minus 2 is equal to 1 over 9. Well, again, same thing. The base here is the 3, right? It's equal to the exponent of the minus 2, and it's a log of the 1 over 9. Okay? The down arrow. Oh, okay, that might be a fair point. All right, so instead of using the little caret that you use, maybe the down arrow. If you have a down arrow thing on your keyboard, yeah, maybe that would work. You can try that. In fact, you want to try that right now? Anybody want to try putting in, see what happens when you hit the down arrow? I don't know whether your keyboard has that capability. You can try that, see if it works, okay, in the chat right now. Go ahead. All right, so there you go, folks. So these are all written in log form. This is exponential form, starting off in exponential form. Ah, okay, all right. Yeah, you could try that. You could try that. Now, yeah, you could try. So put the number first, or the base first, or the log first, I should say. Then use a down arrow, then put the base there. You could try that. All right, you could certainly try that. Okay, so what I've done is I've rewritten each of these in log form. It started off in exponential form, then I got in log form. What about if I had to go the other way? What if I had to rewrite in exponential form? Well, that's not so hard. Again, the base is this thing right here. So I'm going to say, and by the way, this statement is a statement of fact. The log base for 64 is 3. Okay, let's see what you got there. So Jeremy has put the down arrow. So log base 3 of 1 over 9 is equal to minus. So yeah, that works. And Keontae is going with log base 5. Okay, yeah, okay. So I can see how that might certainly work when you're doing this in the chat. But like I said, when you're using D2L or you're using the whiteboard, I'm sure that using the math editor in both of those environments would be better than using the down arrow here. All right. Okay, so let's keep going. Rewrite an exponential form. This is all going to be on your homework in a little while. So the base is the 4, the 3 is the exponent, and there's my statement. There's my exponential form of the statement. So the log base for 4 is 3, statement of fact. Therefore, 4 to the power of 3 is 64. Now this one just says y is equal to log x. Now remember, I don't have an explicitly stated base for the log. So I'm going to automatically assume that that base is 10. So I'm going to say, since y is equal to the base 10 log of x, that means that 10 to the power of y is equal to x, right? 10, which is a base that's implied but not stated here, raised to the exponent, because they say y is the log is this thing here, so the log must be an exponent of y is equal to x. So there you go. All right, so that base raised to that exponent is equal to x. All right, so that's how you go, first of all, from exponential form to log form, and here's where you go from log form to exponential form. Okay, now let's put our log skills to the test. All right, we've done a few of these. Let's see if we have figured this out. What's the base? And I'll take responses from the class for this. What is the base 3 log of 81? Now, I know some of you have fancy calculators that have special keys on it that will do the work for you, but just start thinking about this. I'm looking for an exponent, remember? I'm looking for an exponent on 3 that will give me 81. Try to think of it that way, right? And I see some answers coming in there, and the answer is, in fact, equal to 4. If there's anyone who isn't sure why Harish and Noah and Jeremy got that answer, stop us, stop me. Let's go over it in more detail. Okay? It's important. Could you explain it quick? I sure can, Isaac, and I thank you for asking. Let's do it a different way then, because sometimes I think this is going to help you out. So let's say we don't know what it is for now. So I'm going to erase this answer. And instead of putting that, I'm going to put x there for now, because we don't know what x is yet, Isaac. How about we do this? Let's take that and put that in exponential form. It's in log form now. Let's put in exponential form. What would that look like in exponential form? So we don't need that down arrow for this. Isaac, can you give me what this would be in exponential form? Can you help me with that? Or anybody else, not just Isaac. Can you help me to put that in exponential form? Right, we did that a few pages ago. Take that log base 3 of 81 equals x and put that in exponential form. Anybody? Can you do that for me, please? 3 to the power of x, absolutely. 3 to the power of x equals 81. So the question now is, for Isaac, not just Isaac, everybody else. What number can I raise that 3 to, which will give me 81? So you can try, do trial and error. Try 1. Well, 3 to the power of 1 is just 3. 3 to the power of 2 is 9. 3 to the power of 3 is 27. 3 to the power of 4, oh, here we go, 3 to the power of 4. And therefore, I can state this as 3 to the power of 4. All right, that's what 81 is, 3 to the power of 4. And since the two bases are the same, it means that I can just make the two exponents equal to each other. So x is therefore equal to 4. Does that? Okay, good. And sometimes that's the way that you need to do this. And in fact, we're going to get to one a little while from now, which definitely needs us to take that kind of approach. But let's just keep going for now. Let's get to the next one. Does anybody have an answer for the second one, the log base 2 of 1 over 8. I see a bunch of answers. Carison, Sharisa, and Jeremy and Aliza are all thinking that this is minus 3, and Joel as well, thinking it's minus 3. And the answer is right, it's minus 3. Right? I go through the same process again. I'm going to say that the log base 2 of 1 over 8 is equal to x, because I don't know what it is yet, which means that 2 to the power of x is equal to 1 over 8. And I'm thinking I need to make this 8 have a base of 2. So I'm thinking 1 over 2 to the power of 3 is 2 to the power of x. And this is the same thing as 2 to the minus 3. Right? Remember Mr. Richards talked about that a few minutes ago. And therefore, when the bases are the same, so this is 2 to the x, is 2 to the minus 3. The bases are the same. Oh, sorry. The bases are the same. I don't need the bases anymore. And therefore, x is just simply equal to minus 3. So there's your answer. There's your answer, absolutely. Okay, how about this one? The log of 0. Now, don't run to your calculator, folks. Don't do that, right? That's not going to teach you anything. What do you think the log of 0.01 is? Does anybody think they know what it is? Before I walk you through the process, what do you think the log of 0.01 is? And yes, you can just run to the calculator and get an answer, and then you don't really know what you're doing. But does anybody think they know what the log of 0.01 is? We'll do it in stages. But the first thing we need to understand is that this is a base 10. Right? Doesn't say what the base is, so it must be a base 10. All right? And then here's what I'm going to do now. I'm going to take that 0.01 and I'm going to try to express it as some kind of a fraction. So here's what I was taught in what we call primary school in Jamaica, 0.01. When I want to change that into a decimal, my primary school teacher, Mrs. Combs, told me, put 1 for the decimal point and 0 for anything that comes after decimal point. So that's 0, 0. So that's the same thing as 1 over 100. That works with anything else that you can do, that you want to do. So if this, I'll give you another example then, right? So if this had been 0.005, then put that 1 to decimal point, then put 3 zeros in. So that'll be equal to 5 over 1,000. So it does work. Just saying, it does work. All right, so I'm going to erase all of this stuff here, just taking you back to my primary school days. And I'm going to say that instead of calling this log of 0.0, I'm going to call this log base 10 of 1 over 100, which I just explained to you how that works. So if it is 1 over 100, do you now know what the answer is as to what is the base 10 log of 0.01? Now that I've changed it into a fraction, does that help you to see what the answer is? Okay, you know what? I just realized a bunch of you had the answer from before. It is actually minus 2. Well done. And that's because 1 over 100 is the same thing as log base 10 of 1 over 10 squared. And that is therefore equal to minus 2. Okay. All right. Let's just do this one quickly then. Let me grab this here. Without me going through a lot of hoops, Aliza thinks the answer for the log base 3 of 27 is 3. That means you've gotten really good at this, Aliza. I'm just going to put the 3 down and move on, unless anybody has any other answer for that. How about these two? How about this one here? The log base 4 of 1 over 64. Jeremy thinks it's minus 3. Does that make sense? Well, again, log base 4 of 1 over, instead of calling it 64, I could call it 1 over 4 to the power of 3. Because 4 to the power of 3 is 64. Which would mean I'm asking what's the log base 4 of 4 to the minus 3. And here's something that comes up quite a bit. If I can make this base of the log match the base of the thing that I'm trying to find, and whatever the exponent is the answer. Right? So in this case, the answer is just simply minus 3. Now here comes one that's a little bit tougher. fact, let's see if anybody knows the answer before I tell you what it is. The log base 8 of 4. Uh-oh. A half, Joel thinks. Anybody else want to jump on the Joel bus? Does anybody else think that that answer is correct? Okay, Aliza says it's 2 over 3. Is there any other answer? We've got two different answers. And Ava is also thinking it's 2 over 3. Interesting answers. I'm not going to weigh in yet. I'm asking for some more responses on that. What's the base 8 log of 4? I'm not sure who Jeremy is agreeing with, though. Kale is saying it's 2 over 3 as well. So most of you think it's 2 over 3. And Joel is now going, not a half. Okay. All right. Let me tell you how I would do this one. Let me walk you through how I would do this. Right, first of all, I'm not sure how you guys did it. I mean, I'm assuming I didn't use a calculator to do it. First of all, I'm going to say, okay, set this equal to x, just like we did the last few times. And then I'm going to write this as an exponential form. So what does this look like in exponential form again? I forget. Help me out. Help a teacher out here. What does this look like in exponential form? That's the log form. Give me the exponential form of that same expression. 8 to the power of x. Okay, good. 8 to the power of x equals 4. Okay. Now I'm thinking, I have no idea what I'm going to raise 8 to that gives me 4. But how about if I did this? How about if I change them both to have the same base? Instead of saying 8, why didn't I say 2 to the power of 3? Because that's the same thing as 8, then to the power of x. And then the other side, because I want them both to have the same base, I could say this would be 2 to the power of 2, right? Would that make sense, everybody? Right? So I change the 8, I mean, it have a base of 2. That's 2 to the power of 3. I changed the 4 and made that have a base of 2 as well. So that's 2 to the power of 2. Now, one of the things that you should have learned back in grade 11 is that when I raise one power to another exponent, I can actually multiply those two exponents together. So really what this is 2 to the power of 3x is equal to 2 to the power of 2. Right? Just multiply the 3 and the x together, which gives you 3x. That's legit. Right? With exponents, one of the exponents is called the power law of exponents. I can absolutely do what I just did. So remember what we did before? When the bases were the same, which they are, oh, sorry, let me go back and take that out. When the bases are the same, which they are, I can ignore the bases and say, since both sides of this equation are equal, and the bases are equal, then the exponents must be equal. That means that 3x must be equal to 2. And if I solve this, well, that's just saying divide by 3, divide by 3. So x is 2 over 3. So that's the way I'd like you to think that through, right? That's your answer. So you're all right, right? So kudos to all of you. You're all right. X is equal to 2 over 3. Let me tell you why this answer makes sense, right? And this is an important lesson for us since we're working on exponents and trying to understand what they mean. This means that 8 to the power of 2 over 3 is equal to 4, is what we're saying, right? That's what it means. Because when we were trying to work this out, we start off by putting it in exponential form. It says 8 to some exponent gives us 4. Now, why does 8 to the power of 2 over 3 equal 4? Why is that? Well, let me walk you through how would you evaluate. That's what I'm going to show you now, Jeremy. That's exactly why I decided to write this down, right? What would I do to evaluate 8 to the 2 over 3? There are actually two ways of doing it. I'm going to do the easier way first. When I have 8 to the power of 2 over 3, it means that I'm taking the numerator and raising it to that numerator, and the denominator is going to be a root. So what that means is this. It's the cube root of 8 raised to the power of 2. So I took the numerator, sorry, let me start with the denominator, and made that into a root. I took the numerator and made that into an exponent. So I'm raising it to that number. So I'm going to first of all find the cube root of 8, right? And the cube root of 8, of course, the inside part of that is 2. Then I'm going to take that number and raise that to the power of 2, which of course is 4. Now, I mentioned there were two ways of looking at this. Well, the other way of looking at this, 8 to the power of 2 over 3, is to take 8 and square it, and then take that number and cube root it. Both, Aliza, okay, Aliza, both actually give you the same answer. So I reverse the process. In the first one, I cube rooted it first, and then I raised it to the power of 2. In this case, I'm raising the power of 2, and then I'm cube rooting it. So let's go through the process. That means I'm looking at the cube root of 64. Well, guess what, folks? That's still 4. So either way, you're still going to get that 4. So what does 8 to the power of 2 over 3 mean? It means one of two things. Either I'm squaring the 8, then cube rooting it, or I'm cube rooting the 8, and then I'm squaring it. The order does not matter. Now, what if this had been, let me give you another example. Let me give you another page here. Excuse me. What if this had been 16 to the power of 3 over 4? What do you think that would mean? Does anybody know what the answer is, first of all? It is 8. And that's because what I'm doing is I'm taking the 4th root of 16, then raising that to the power of 3. Now, for those who don't know, the 4th root of 16 is 2. That's 2 to the power of 3, which of course is equal to 8. Now, could I have done it by raising 16 to the power of 3 first? Yes, and then find the cube, the 4th root of that? Yes. Except I don't know what 16 to the power of 3 is. I honestly don't know. I need a calculator for that. The other one I could do without a calculator, right? But if I did it that way, 16 to the power of 3, and then found the 4th root, I'd still get 8. I would still absolutely get 8. Okay, so here's the other thing I'd like us to do before I'm going to give you a chance to get your homework started, which is this. Finding inverse functions. What we just learned is that the inverse of an exponential function is a log function. So if I have a log function, could I turn it back into an exponential function? And if I have an exponential function, can I turn it into its inverse log function? Absolutely, we can. That's what we're going to do right now. We're going to try both of these. So I'm going to start with the one on the left. When you're trying to find inverses, try to remember that the goal is to exchange your x with your y. That's what an inverse function does. An inverse function flips the script. So what was your x becomes your y, and what was your y becomes your x. And let me just tell you a little bit more about an inverse function. What an inverse function really does is it reverses the effect of the original function. So if your original function, you put 1 into it, you got 9. When you put 9 into the inverse function, it's going to spit back out the 1. Just saying. Okay? So I'm going to show you how you can take the inverse of this log function and put it back into an exponential form. So first things first, why don't I exchange my x with my y? So I'm going to say that x is equal to 3 log base 2 of y minus 4 minus 9. Okay, let me just erase this line here. I put that back right there. So the first step in the process is to exchange y and the x. Some people do that at the end, by the way. I just choose to do it at the beginning. But let's just say that it's now done. X became y and y became x. Now my goal is to isolate the y. Can anybody suggest what the next step might be in isolating that y? What do you think my next step would be to isolate that y? What can I do to the two sides of the equation? It seems hopefully fairly obvious. Okay, moving the 9 to the left. When you say move it, tell me, be more specific. Add it. Correct. I'm going to say x plus 9 is now equal to 3 log base 2 of y minus 4. Okay. Okay. All right. So what do you think? Okay, Lisa, great. So what do you think now, folks? What's my next step in the process? I'm still trying to get that y on its own. It's still not there yet. Right? Okay, divide by 3 on two sides. I like that. So x plus 9 divided by 3 is equal to the log base 2 of y minus 4. Absolutely. Well done. Okay, so I've done that. So the base 2 log of y minus 4 is equal to x plus 9 divided by 3. That makes sense. But we still have this log that's kind of preventing us from having an equation that says y equals. So I'm stuck again. I need your help. I'm really not sure what to do now. This log is in the way, right? I need to get rid of this log. Is there a way that I can get rid of this log so I can get that y on its own eventually? We divided by 3. I took your advice, but now the y is still stuck in this bracket with the log base 2 in front of it. Does anybody have any ideas as to how we might be able to get rid of this? Is this not like 2 to the... absolutely, Jeremy. So what we're going to do is we're going to put this in exponential form, like we were doing before. In exponential form, because the base is 2, we're going to say that 2 to the power of the x plus 9 over 3 is equal to the y minus 4. Does that make sense, everybody? Right? The base of 2 raised to this number here, which is an exponent, is equal to what we were taking the log of in the first place. So it means you only have one more step now in order to get this inverse. And that's to add the 4 to the two sides. So now we eventually have our exponential form of the function. Y is equal to 2 to the power of x plus 9 over 3 plus 4. This is our inverse function. That is our inverse function. If I were to put both of these on a graph, if I put this log function on a graph and this log function on a graph, you would notice that there seem to be reflections across that y equals x line that you saw Mr. Richards doing a few minutes ago, right? So if I were to graph them both, I'm not going to do that right now. You can try this out later on when you're watching the video. Graph them both on Desmos and see if they reflect across the y equals x line. Okay, let's try this again over here. Same idea. I want the inverse. Now that you've seen me do this once, I'm looking for the inverse function of this y equals minus 2 log 1/2 x plus 3, minus 3 at the end. So first things first, I'm going to flip the x and the y. So I'll do that part for you, okay? I'm so generous, I'm going to do that part for you. So I'm going to say that x is equal to minus 2 log 1/2 of y plus 3 minus 3. Okay, I've done that, right? I was so generous, I decided I would do the first step. Maybe because I don't know what else to do. So I thought I'd just do the easy one. So there's the first step. What do I do now, folks? Help me out. Now that I've done that, what's next? Add the 3. Okay, we'll do that. So x plus 3 is equal to the minus 2 log of 1/2 y plus 3. Okay, so I've done that. All right, so thanks, Karis. Thanks, Isaac. Thanks, Joel. What do I do now? Divide by minus 2. Okay, I'm pretty sure that makes sense. So x plus 3 divided by minus 2 is equal to the log of 1/2 y plus 3. Okay, done that. Thank you very much. Good stuff. Good stuff. Now what? Write the exponential form. Okay, Harish. Okay, you do that then. Write the exponential form. What's the exponential form? Isaac says 10. See that? That's the thing I wanted to make sure you understood. I didn't have a base explicitly stated, so it must mean that the base is assumed to be 10. So 10, let me write this side first. 1/2 of y plus 3 is equal to 10 to the power of this x plus 3 divided by minus 2. Okay, so I think everybody is okay with this now. Should we move the minus from the minus 2? Yeah, we'll do that in a minute, Jeremy. So I'm going to know minus 3 from the two sides. So 1/2 y is equal to 10 to the power of x plus 3 divided by minus 2. And then we're going to say minus 3 to that. And then how do I get rid of that half now? How do I get rid of that half? Anybody? Anybody out there? Half of one side. I want this to be multiplied by 2. I think that's the best way to do it. So if I multiply the two sides by 2, I'm going to get this. Y equals 2 times 10 to the power of x plus 3 divided by minus 2 and minus 3. 2 is being multiplied by everything, by the way. Now, as a personal preference, I don't, and Jeremy kind of made the point earlier, I don't particularly like when a denominator is negative. This is not like this is necessary, and I'm not going to insist on this, but here's what I would prefer to write. I prefer to put this as 2, 10 to the power of minus x minus 3, put it in minus on the top, over 2, and then minus 3 on the end over there. Okay, so am I going to take marks off of that? Absolutely not. Absolutely not. That's, that's window, what I call window dressing. All right, some people prefer to have their denominator positive, like me. Some people don't care. And maybe you're one of those who doesn't care. And I think that's perfectly fine in a free society for you not to care whether it's a minus on the top or on the bottom. I just applied the minus to the top, but the minus does apply to both though. What I'm doing is I am taking that minus on the 2 and applying it to the top. So you're minusing both the x and the 3 as well. It's like multiplying the top by minus 1 and the bottom by minus 1. That's essentially what I've just done. And again, that represents the the exponential form of that equation. Actually, since we have a couple of minutes, how about if I gave you, so we started off with a log form and made it into exponential form. How about if I gave you, I see a hand going up. For the other equation, can we add the 4 to the 2 and should it be, or should it be separate? Okay, for the other equation, let's just see now. No, you can't. If I'm understanding you right, you can't add the 4 to the 2, and I'll tell you why that is, Keontae. Exponents come first. I have to raise 2 to the power of this thing here first before I add on the 4. Remember BEDMAS? So it would be absolutely incorrect for you to add that 4 and that 2 together. Okay. All right. Somebody else had a hand up, I believe, or did I answer all the questions? I can't remember. No, I thought I saw like a hand was going up. All right. Let's just do. Oh, sorry. Yes, no. Go ahead. Yeah. That's it. Yeah. Yeah. That's good. Like I said, the line before it would have been acceptable as well. It's just a matter of personal choice. I'm going to do one more thing before we give you the chance to do your homework. What if I started off with, so remember, these were log equations. What if I had an exponential equation that said that, I don't know, y is equal to 4 to the power of 6x plus 5. I just made that up on the fly. That's an exponential function, right? What if I wanted to come up with the inverse of that function, right? What would be my first step in making that a log function? Can I make this into a log? That's an exponential function. If I put this on a graph, it would be exponential. What would I do to make this into a log function? Its inverse function, which is a log function. What do you think? Anybody? Where do I start? What's the first thing? What do I always start doing to make this exponential? Yeah, I think that's a good idea. So x is equal to 4 to the power of 6y plus 5. All right. Okay, we've done that. We've done that. Now what? Now what do we do? Can we put this in a log format? Is there a log form for what I have there right now that anybody can think of? Of course, now we get to the point where we have to use subscripts, and that's the thing that maybe some of you aren't so sure about. Oh, look at that. Jeremy was using his subscript there. So the log base 4 of x equals 6. Okay, good. So the log base 4 of the x is equal to the 6y plus 5, the exponent that we had in the first place. So of course, we now can finish this up by saying, since this is the log base 4 of x is equal to that, I'm just going to simply say the log base 4 of x minus 5 is equal to 6y, and therefore y, I'm just going to finish this up very quickly, and therefore y is equal to the log base 4 of x minus 5 all divided by 6. Sometimes my subscripts don't look very much like, so this is not the log of 4x. Let me just say that. It's the log base 4 of x. And I want to make sure that we do this, right? Actually, no, that's not right. It's a log base 4 of x on its own. I was just thinking that it was a log base 4 of everything, but it's not. It's just a log base 4 of x. So it's a log base 4 of x, and the minus of 5, then divided by the 6. So let me not confuse you by writing anything down which is incorrect. All right, so I'm going to stop the video.